Two cars are approaching an intersection. One is 1 mile south of the intersection and is moving at a constant speed of 40 miles per hour. At the same time, the other car is 2 miles east of the intersection and is moving at a constant speed of 10 miles per hour. So in this question, what we want to do is we want to express the distance between the cars as a function of time. So at t equals 0, the cars are 1 mile south and 1 mile east of the intersection respectively. So this is going to help us with our picture. So we're going to draw a picture to represent that intersection. So here are the two roads crossing each other. And we're going to label the north of the intersection, east of the intersection, south of the intersection, and west of the intersection. And so one car is going to be a mile south. Let's use it here. So there's one car. And another car is 2 miles east of the intersection. And we want to express the distance between these cars. The cars are moving, one at 40 miles per hour and one at 10 miles an hour. So we could measure the distance between these 2 points, but it's constantly going to be changing. So it's not going to be a distance that is a numerical answer. It's going to be a distance with a variable. So what I'm going to do is I need to represent this distance here between the intersection. It starts off being 1 mile, but that distance is getting smaller because of me traveling towards the intersection. I'm traveling at 40 miles per hour. So I'll say 40 times x. So 1 mile minus 40 times x. And then the other car is east of the intersection, and it is 2 miles away and traveling at 10 miles per hour. So I'm going to subtract 10x. And if you're not sure what I'm doing here, I'm using the formula distance equals rate times time. I'm using distance equals rate times time. So this is the rate and this is the time. So I guess I should be using t instead of x. So this should be t and this should be t. So 1 minus 40t and 2 minus 10t. And then if I want to find the distance between these two cars, I have Pythagorean Theorem. This is a right triangle. And Pythagorean Theorem tells me that this distance can be found by doing 1 minus 40t squared plus 2 minus 10t squared equals that distance squared. And if I square root both sides, I get the formula square root of 1 minus 40t squared plus 2 minus 10t squared. I'm going to do a little bit of simplifying on this formula. Let's simplify the squareds inside the radical. That's 1 minus 40 times 1 minus 40. 1 minus 40t plus 2 minus 10t times 2 minus 10t. So that will be 1 minus 40t minus 40t plus 1600 t squared. 2 times 2 is 4. 2 times 10, that's minus 20t, and then plus 100t squared. I have some like terms I could combine. 1 and 4 combined together to be 5. I have like terms of negative 40, that's negative 80. Another negative 20, that's negative 100, that's negative 120 t. And then I have like terms of 1600 t squared and 100 t squared. So those combine together to be 1700 t squared. So this function is going to give me the distance between the two cars at any moment of time. Okay, so then we want to use that formula that we've created to answer this question. We want to use a graphing utility to find what value of t produces the smallest distance. So there we're going to use our TI graphing calculator. And let me clear out these buttons here so you can follow along. So in my y equals menu, I'm going to type our function. It is the square root of 5 minus 120. I'm going to use x plus 1700 x squared. And I'm going to take a look at the graph. Now, these are very large numbers in the problem. In my graph, the standard viewing window is usually negative 10 to 10. So I'm going to show you what it typically looks like. The standard viewing window typically looks like this. It doesn't give us a very good picture of our graph. So I'm going to try a couple things so that we get a better picture. I'm going to hit zoom, and I will use, see, it might be at the bottom, so I'm going to hit up to get to the bottom of the list. Okay, I'm going to use this one here, zoom fit. Zoom fit is when your calculator tries to figure out what the window should be. It doesn't always work exactly how you want it, but it'll make a guess. So I'm going to try that. And I can see the picture a little bit better now, and this bottom part here where it dips down, that's going to give me the smallest distance. I want to zoom in on that a little bit better, so I'm going to change the window so that my low is a little bit lower. So I'm going to go, since my high is 400, I'm going to go down to negative 100 just so I can see that dip a little bit better. So now we see that dip in the graph, bottom out. And I'm going to hit, in the calc menu is where I find the minimum. So I'm going to hit second, trace. Number 3 is minimum. Minimum is the smallest value. And I want to make sure I go to the left of the minimum and go to the right of the minimum. And then make a guess about what the minimum is. And hit enter. And it's going to tell me here that my minimum occurs at a time of 0.035 hours. Which makes a lot of sense to me because we are relatively close to the intersection already. So these two cars are going to get close to each other very quickly. So the minimum occurs, the smallest distance occurs 0.035 hours from this initial moment when We have the car south being 1 mile south and the car east being 2 miles east. Thank you for checking out my videos. Have a great day.